Hey, my name is Bern Grush, and I am the Executive Director of the Urban Robotics Foundation. I am excited to take a look with you today at the direction last mile delivery as a service is taking and the dramatic impact that e-bikes are having and the impending introduction of delivery robots and how those can be managed at scale, and most of all, how they might coexist with e-bikes in the future. Briefly, my background begins with human factors and system design engineering. I moved through careers spanning AI and remote sensing and systems integration. And since the turn of the millennium, I have focused on ground transportation. Most recently, I've been involved with writing standards for what are called public area mobile robots, of which delivery robots are an example that we will be talking about today. Package delivery in cities has relied on motor vehicles and bicycles for well over a century. Food and grocery delivery have risen dramatically over the past several years, and recent innovations include massive aggregators such as DoorDash and Uber Eats. Optimizations include cargo bikes and e-bikes, and now we're starting to see robots, including follow-me robots and critical ancillary technologies such as micro-lockers. Everyone here knows that e-commerce has been growing dramatically, and that it has been recently boosted during the COVID pandemic. After a remarkable spike in 2021, e-commerce continues to grow each year. It will likely begin to plateau by the end of this decade, then saturate, relatively speaking, over the next decade or so. On an absolute basis, you can expect it to continue climbing until human population plateaus or some other major disruption. No matter how you look at it, there is a massive change engine driving last mile delivery. Here is a World Economic Forum illustration that was prepared just before the pandemic started. This already shows more delivery endpoints, customers, stuff being delivered, delivery volumes, and methods optimizing those deliveries. Of course, the pandemic accelerated that. Note that this illustration is out of date. In the lower right corner, the assumption that there will be highly automated and fully automated vehicles by 2024 was wrong. That was already known to be unlikely a few years earlier, so this is simply an example of the World Economic Forum succumbing to hype. Today, it is certain that this will not happen within any immediate time frame. What does appear possible in the near term is the introduction of public area mobile robots, at least in modest numbers. This talk will focus on one type of those delivery robots. What are the change factors that are operating to cause e-commerce to grow and food deliveries to surge? We're staying home more. We're getting older, busier, and maybe a little lazier. In response, gig delivery has been growing, and now e-bike use is expanding and delivery robots may become significant. They are already here, but their numbers are still tiny, several hundreds, not millions. And while that's happening, we are experiencing a labor shortage and aging population throughout most of the world. You can see the projections for three major populations, China, US, and Japan, all projecting increased proportions of people over 60, even as we continue to urbanize. So we will increasingly require help from automation. If you are in the e-bike business, this will appear to be competition as robots start to get better, however slowly. But what is noticeable is that delivery as a service operators can leverage fleets of robots by integrating them with bikes and e-bikes. Here's an example from earlier this year. The robotics startup that has Uber as one of its shareholders has just added Uber Eats deliveries to its existing roster of restaurant customers in Los Angeles. If this proves successful, and it is highly likely that it will, this may spread quickly, at least in cities with the right conditions. How this works is that a customer can voluntarily choose a robot delivery option if it's available for the order that's being made. Uber Eats can only assign a robot if the required trip is mapped and reachable by a robot. This is certainly not true everywhere. At the end of the line, the customer needs to come out to the sidewalk, unlock the robot with a smartphone, and take their order. Soon, there will be no reason that this cannot be extended to any same-hour small package delivery. And for non-perishables, there may soon be a micro-locker, perhaps only a few meters from the receiver's end location, so that a robot need not block pedestrian traffic while waiting for a customer to come to the sidewalk. There are companies working on this, but solutions are still to be worked out. The end result of these changes is the decline in the use of motor vehicles for last mile delivery. These will continue to be replaced by bike, e-bike, and delivery robots. Motor vehicles will still be used for large deliveries and for rural areas. Human-powered vehicles will plateau. crowdsourced delivery will continue to grow. That growth may be mediated by micro-fulfillment centers that can shorten trips while increasing trip count. E-bikes may lose relative demand to robots, but still sustain absolute demand. Two critical things about this drawing. First, this is merely an illustration. On the left is a rough representation of where we are now, and on the right is the likely direction we are heading. Specific proportions cannot be reliably predicted. Secondly, this is relative. From an absolute perspective, the volume on the far right may be 2 or 3 times the volume on the far left as this saturates. That means while the relative e-bike proportion of deliveries may plateau or even decrease, its absolute volume will continue to increase for the foreseeable future. In the near future, we can expect e-bike use to continue rising, competing with both the motor vehicle and the pedal bike. Not only does this take motor vehicles off the road, but we get more deliveries per shift, which one hopes translates into better working conditions and payouts. As well, e-bikes allow older workers to work without driving a car. It is also critical that e-bikes can address labor shortage because they attract workers to a better working condition and higher daily delivery counts. Note in this illustration that micro-fulfillment and crowdsourced delivery may both involve e-bikes. These categories are simplifications. In the middle future, we expect motor vehicle use to continue to decline, and we can expect more delivery robots, but for a number of infrastructural, regulatory, and operational reasons, these robots will appear far more gradually compared to the relatively sudden rise of e-bikes. Robots change the labor requirement because they still require remote operators. And if labor shortage continues, this will incentivize innovation to reduce that burden as well. Robots will not be distributed uniformly to the degree that the e-bike has experienced. In other words, a few of you may see many robots, and many of you will not see any, even in this middle period. In the longer view, say 2 or 3 decades, the pedal bike will continue a relative decline. Remember, this illustration is relative to 100% of the deliveries. A combination of micro-fulfillment and crowdsourced delivery will keep the e-bike and its human operator dominate because of all the complexities I mentioned previously. Robot deliveries will grow. They may match or outpace motorized vehicles in this time frame, but it is optimistic to project that they will surpass human delivery volumes. Nonetheless, shipping aggregators will need every method available so that you will see carriers increasingly do what Uber Eats is trying in Los Angeles. They will slot in robots where they can. This will become important to the companies that rely on crowdsourced human delivery. As solutions, robots are not always suitable, but where they are suitable, they are easier to assign and schedule. It is that pliability that makes them most attractive in the right circumstances. In the end, it is these aggregators that will recover the maximum competitive value of these robots. So here's a quick summary on the business side. It is the delivery and carrier aggregators that will favor robotics. They will seek to have them improved. They will lobby to have them permitted, etc. Deployment complexity, such as regulatory infrastructure or weather conditions, currently favor e-bikes. These same barriers challenge robotic innovation. On the other hand, business reasons, including labor costs and shortages, will continue to favor robotics. If last-mile delivery aggregators and carriers are smart, they will organize themselves so that no one really cares how a delivery is executed, except that it be completed quickly, reliably, and cheaply. Robots may eventually rival e-bikes, but this will take a couple of decades. But there are many other forms that competition takes. For many cities, especially North American cities, the sidewalk is what's left over after roadway and parking spaces are reserved for motor vehicles. Now we are pushing dining tables, e-scooters, bike rentals, charging stations, and dozens of other activities into this constrained space. How will we add robots to that? We're going to compete for the public right-of-way. Depending on your city, bikes and e-bikes already compete for space. Where you have cycling lanes, which are sparse in many cities, you already see competition. I'm speaking to you from Toronto, where we have only a few bike lanes, and we already have many bikes, scooters, and e-bikes using the sidewalk. Sharing cycle lanes has a lot of problems. Differential speeds and weights are one thing, but having them get on and off the cycle lane means e-bikes frequently use the sidewalk. Adding robots to this spatial competition will be complex, depending on the existing infrastructure in any particular location. This factor alone severely complicates the question of e-bikes versus robots sharing these public spaces with pedestrians and cyclists. This entire issue will be critically focused on the crosswalk at traffic intersections. This is not a simple problem. The time and place for robots will be constrained for the immediate future. This means that the direction of e-commerce is toward smaller form vehicles. The need to reduce motor vehicles on city streets will add further pressure to expand active space for microforms such as e-scooters, bikes, e-bikes, and robots. So we end up having to choose between a zero-sum game of competition or banning some of these forms of transportation. Some cities have already banned robots as well as e-scooters. Or we consider a collaborative game in which we widen active mobility space and make that space viable for growing fleets of all these microforms for passenger and goods movement. If we choose such a collaborative game, we have an opportunity to make our cities more accessible for all. Existing automotive and air travels are managed by orchestration systems that are standardized and overseen by government authorities. For all these same reasons, robotic traffic in our public urban spaces will require multi-agent orchestration. Even if we address the numerous spatial and business contentions that I have just described, it is still the case that there will be multiple fleets of public area mobile robots, each attempting to independently set out their own purposes, tasks, and optimal routes. This must be managed. Starting in the upper right of this diagram, an orchestration manager, which is essentially a regional traffic manager, would take trip requests from a fleet operator and offer that operator a trip plan for its robot. Such a regional orchestrator provides traffic control and congestion management, including constraining robots in certain areas and times. This is analogous to air traffic control, and it is outlined in ISO draft standard 4448. Each robot operator then manages its multiple robots in a way that conforms to the regional orchestration manager, but that orchestration manager does not need to know the private reasons for each robot activity. This provides traffic control while protecting business and personal privacy. This is the data exchange for an orchestrated small robotic freight trip. It also applies to any public area mobile robot that may be on its way to a maintenance or security assignment. The idea is simply that a trip request provides a start and end location, preferred arrival time, and equipment description, the size and nature of the robot, any hazardous goods description, and any special tools with respect to the task the robot is to carry out. The results coming back from the orchestration manager to the fleet operator, again, analogous to an air traffic control system, is a trip plan providing a map, departure time, and specific behavioral rules for that trip. There would likely be a negotiation capability as well. Now we ask the question of what happens if a dispatcher, such as in the Uber Eats example I just showed, has at its disposal both e-bike and robotic delivery agent. Should such an orchestration system be able to coordinate both? Currently, ISO 4448 only considers robotic agents. This may not be sufficient, so this is still work in progress. Let me wrap up by saying that the Urban Robotics Foundation is a membership-funded nonprofit. We prepare municipal readiness guides, draft international standards, provide courseware and advisory services related to deploying mobile robots in public spaces. We do not make or sell robots. Our members are from governments, planning organizations, accessibility advocacies, technology companies, logistics operators, academics, really anyone with a stake in public area mobile robots. And to learn more, visit our site, request a free executive guide to public area mobile robots, attend our webinars, and consider joining us. Thank you.